Hi, this is Algebra 2, Lesson 10. We're going to talk about the Pythagorean Theorem. We're starting on page 59 in your book. We've talked about the difference between properties and definitions. Properties describe the way things are, and definitions are things that have been agreed upon. So, for properties, we have things like 3 plus 2 equals 2 plus 3. Or, if A equals B, then A plus C equals B plus C. Right? These are properties. That is just the way they are. This is the way God set up the world. This is the way numbers work. Then there are things that mathematicians over the years have agreed upon. For example, that x to the negative 2 equals 1 over x squared. X to the negative 2 didn't have to equal 1 over x squared, but some mathematicians got together and decided that was how they were going to write it. And we've been writing it that way ever since. Or 4 plus 3 times 2 equals, well, if we start here, this is going to be 4 plus 3 is 7, times 2 is 14. Or if we start here, 3 times 2 is 6, plus 4 is 10. And some mathematicians got together and decided what order we're going to do math in. So we start with the multiplication and then we add. So that it equals 10. Both properties and definitions can be called rules. Another kind of a rule is a theorem. Like properties, theorems describe the way things are, but they are proven to be true by a mixture of properties and definitions. The Pythagorean Theorem states that the area of a square drawn on the hypotenuse of a right triangle equals the sum of the area of squares drawn on the other two sides. I know you talked about this every year for the last several years. We're going to talk about it again. This probably isn't the last time you're going to see it this year either. Okay, so here we have a triangle. This side is 3 squares long. This side is 4 squares long, and the hypotenuse is 5 squares long. And the Pythagorean theorem says that if you take this 3 and pull it out and make it a square, and you take this 4 and you pull it out and make it a square, and you take this 5 and you pull it out and make it a square, then the area of this square plus the area of this square equals the area of this square. And of course, area of squares is length times width, so this would be 3 squared plus 4 squared equals 5 squared, or 9 plus 16 equals 25. Okay? Which means, because to get the area of the square, we're squaring this length of this triangle. That means that 3 squared plus 4 squared equals 5 squared. Right? So the resulting algebraic equation, which you know already, I'm sure, is c squared, which c is always the hypotenuse. C squared equals a squared plus b squared. Okay, this theorem is proved in geometry. For now, we're going to use it as if it were a property. So, here's an example. Use the Pythagorean theorem to find side A. Here we have a side that's 4 units long. This one is 7 units long, and here is A. Okay, this is the hypotenuse because this is the right triangle, or the right angle. So we can say 7 squared equals 4 squared plus A squared. We can solve for A by moving this over. So now we have a squared equals 7 squared minus 4 squared. 7 squared is 49. 4 squared is 16. 49 minus 16 is 33. So A is going to equal the square root of 33. And we can't simplify that further. Okay, here's another one. Use the Pythagorean theorem to find the distance between points 4, 2 and negative 3, 4. Last year we learned the distance formula, which we derived from the Pythagorean theorem. Right now though, we're going to do this the old way and graph the points and form a right triangle. And later in the year this will be back and we'll go back to the distance formula. So I graphed the points. Here is -3 and 4. Here is 4 and 2. We're going to make a line between them. And this is our distance. So this is going to be our hypotenuse. We're going to turn this into a right triangle by dropping down the y and then moving towards the x. Okay? This distance is the distance between 2 and 4. So this is just 2. This distance is the distance between -3 and 4. So 4 minus 3 is 7. Okay? And this is the distance we want to find. We're going to call it C. We could call it H for hypotenuse. When we're doing distance formulas, we usually call it D. So we know that C squared is going to equal 2 squared plus 7 squared. And that's going to equal 4 plus 49, which equals 53. So C is going to equal the square root of that, because this is C squared. So this is going to equal the square root of 53. And there's nothing more you can do with that. Okay? That is it for this lesson. Try the practice problems and do your homework. Let me know if you have any questions.